will remember the Bubbleator, the Wobbleator. Actually, that thing with the long coils, where I had the steel laminations going all the way through the coils on the inside and on the outside. Well, during those previous tests, I used to get acceleration when there was a load on it. It was very subtle. It wasn't not predominant. I used to use these cores, which I still have, these welding rod cores. I used to have these welding rods with a ball not a ball bearing, a round piece of metal on the end, a ring on the end. And as the rotor used to pass the core that was on one side of this, the opposite pole would be on another one on the other side. And at the time I didn't really recognize the significance, but what used to happen was that the lens effect used to travel along the core material, and whatever anti-drag was on this side was the opposite anti-drag on this side, and the two anti-drags used to cancel each other out. So we used to reduce the drag on the system, but it was very inefficient in producing decent amount of voltage and current on the output. It was very small, actually. Well, I can't show you those other coils because I'm not sure where I put them, but I've got these other coils which are covered in dust, actually. They've been up on my shelf. And so anyway, I had an idea earlier. Now basically what happens is, to show you what I mean with the coils, normally when you energize the coil from this side, say with a particular pole, the lens effect is reversed on the opposite end. So whatever drag you have on this side, the opposite side produces an opposite lens in effect, which if you can actually utilize that opposite field, you would cancel out the drag, basically. But it's difficult to do that unless you actually have a system where you have two magnets moving past each side at the same time, and you've got to be the timing's got to be perfect as well. But I was thinking about a new design for my Antidrag Generator, which is there at the moment. As you can see, the coils are wrapped around, and I was doing some experiments with. My charge lead's plugged in. I was doing some experiments with these old coils which I made previously, and obviously there's two separate coils and they're holding together. This is an old one I was using for the solid state device, actually, that wasn't moving, and I was holding one of these up against the rotor assembly earlier tonight. And what I found was the amount of drag that comes from this was very small. The amount of lens effect was very small. I put it on my meter and under short circuit load, and it was producing 1 volt at 50 milliamps. So 1 volt shorted at 50 milliamps, and the amount of drag I saw on the actual RPM was only about 10. It only dropped about 10 RPM when I was holding this up against the canopy. I thought, that's interesting. That was when I was holding these flat, by the way. Instead of the coils, instead of being like that, I held one at the top coil, and I rested the top one across the top beam as well, and sort of like that. And that made me think about something, and so the idea I have is if I make some coils that are like little flat sandwiches. So imagine we have like a fan arrangement. So if I draw I'll explain in a second. That's probably in the wrong place, but it's near enough. I'll explain why. I'll do another one here actually. Right, imagine that we have coils wrapped around these. Now each one of these is a flat plastic former of some kind. So it could be just let me see. I can't find anything I can use. Imagine that this is one of these, and that's edgeways. And now imagine we wrapped our coil all the way around this. It's obviously too big for that. Imagine we wrapped our coil all the way around this, and it's like a flat disc, and that takes the place of one of these. And then we have another coil wrapped around one of these, and that becomes the second one. Oops. And then we have another coil wrapped around this, and that becomes the third one, and so on, like a fan shape. Now the reason for that is, if we do that, then what do we have? Well, as the rotor is moving through, the magnetic field, when the actual magnets are directly below here, we have the field will fan out, which is what you want anyway. So, but as the field is on approach, the field is actually coming out to the side of the coil, right? And then it biases the top end, and then it travels through as it's moving through. It starts to bias the bottom end as well. So what happens there is that the field is, instead of being resistant, it helps it to accelerate through, because whatever attraction you have at this point over here, whatever lens effect you see over here, actually becomes an attraction over here, basically. So let's imagine that the rotor's moving, and you have a magnetic field in the middle. It will travel out through all of these fanned out areas, and so that's my idea, and that would gain us more output, having individual separate coils. But as you travel out the other side, and the coil, the magnet assembly is to the edge, then the field tapers off, and whatever energy is travelling through the coils, it should, because if this is sticking at this point, if this part of the coil is pulling against the magnet, then this part should be deflection and pushing it away. So we should gain acceleration. Anyway, that's just an idea I had. It's a bit similar to when you have a coil that's mounted on its side, like so. It's a little bit similar on the side. The only problem with that is that the field isn't orientated directly through the coil quite right. So I thought, by doing it like this, by having a series of little coils, so I'm thinking about making a model, SketchUp model, and what I can do is just wrap a few turns of wire around each one, and mount it on the back of my canopy, on the back of here, just to try it out, because I am really curious. Let's say I put 10 turns of wire on each one of these, and they're all wired in series. I'll be very interested to see the amount of drag that it imposes on the rotor assembly. And yeah, because as I say, when I put this on, half of this up against the rotor, I was drawing 50 milliamps at 1 volt. 1 volt was generated across one of these coils, and it was shorting at about 50 milliamps. Okay, I know that it's relative to watts is relative to the voltage and the current, because obviously the higher the voltage, the greater the impact on drag you have. So 1 volt is a very small amount anyway to be measuring, so I'm well aware of that, but it still seemed quite significant to me in the fact that it didn't impose a great deal of drag. There's a lot of turns of wire on here actually, there's quite a lot of wire on here. It's only thin, I think it's 34 maybe SWG, I'm not sure exactly what it is, but I've forgotten now. But anyway, so because rather than stagnate and get stuck, I wanted to look at other possible options. There's bits of dust flying around here. So yeah, just let me know what you think in the comments anyway, if you think that might be worthwhile trying, because I do have some quite thin wire as well which I can experiment with just to try the idea out. Yeah, okay, so just another idea I've had. Bye for now.